Hello, everyone. So, thanks for joining us today. We will present you a little workshop on how to connect a Ledger device to a web application. So, I will quickly introduce you to the different ways of doing it, and then we will have a live demo with Kevin, and I will go around the room to help you if you need to. And we will even provide some Ledger devices in order to run the workshop. If you don't have one, if you have yours, you can get it out and get ready. So first, as you know, we have two flagship devices, the Nano X and the Nano S and Nano S Plus, which is just a new version of the Nano S. The Nano X has Bluetooth capacity, and Nano S and S Plus only USB. So basically, when you want to integrate your web app or your desktop app with Ledger, you will need to choose a transport method. For web apps, we have three available options: Web HID, Web USB, and Web Bluetooth. It's worth mentioning that Firefox doesn't support Web HID and Web USB anymore. If you want to do a mobile application, we won't be doing it today, but it's React Native HID and React Native Bluetooth libraries. They're also there. And for the desktop app, it's Node.js only, so not HID. And so we will get a small live coding demo. So we will use Vite.js. So Kevin.
Hello, everybody.
Leave you the floor.
So yeah, the goal will be just to show how quickly you can interact with the Nano if you want. There is no need. I know sometimes you might think that you need some adapters and everything that can be provided by libraries like Ethers or some other things. But if you directly want to interact with a Nano from your dApp, from whatever you're building, your wallet or whatever, you can already do it very quickly. And there is no need for something specific. Of course, if you want to have a better UX, sometimes you will have to write your own code just to make sure that the Nano is in the right state and everything, just to be able to know when you can launch it and what actually is the user already doing. But for some very quick example, you should see that you don't need much to get it started and to get support for the Nano right away. Okay, so we're just going to start by creating a small web project, and it's going to be using Vite just because it's a bit quick it's a quick boilerplate to have. So yeah, let's start with that. Okay, so I can just start creating a project. Doesn't really matter how it's called. Let's see. I'm going to do a React project because probably if you're a front-end dev, most of the time you're going to work with React, or actually that's probably the most common one. We're going to do JavaScript just to make it simple. I can now go into my project, and I'm just going to need to install a few more libraries. So the first one is going to be, of course, this is going to be an example with Ethereum, but you can imagine using that with absolutely any Nano app that we have. So we're going to install the hw-app-eth, which is what we call the app binding. An app binding is literally just a one-one relationship that you can have, one-one interface that you can have with the Nano app. Making sure that you can just ask the very basic method, and you don't have to understand how it's communicating. You don't need to understand much. Just use the very simple interface that is already in it. And we're going to add a few transport layers. So I'm going to install WebBLE, so you can see that it's working with Bluetooth at some point. But first, we're going to use WebUSB. So you just install WebUSB as a transport, and that's going to be provided to the app binding that we installed first. So you can just have a very simple interaction. You don't need to think about it. Again, it's just going to instantiate a transport at some point. Everything is handled for you. You just have to provide it to the app binding, and it's going to do everything by itself. And I'm going to install ethers. I'm just using version 5 for because I'm just more used to do it with it. You can install 6 if you want. And buffer because we're in a browser context, and at some point we're going to need to create some exa strings, and it's going to be easier with a buffer with buffer installed. And yeah, light precision. I'm using the version 6.33 for the app binding, just because we discovered a bug this morning with parcel and VGS because bundling. But yeah, don't use the 6.34 right now. If you want to use Vite, it's not going to work for just bundling reasons. But anyway, let's just install that. Should be pretty quick. And once you have that, you're basically good to go to do all the rest of the workshop. Hopefully the Wi-Fi is good with us, and I have that quickly. Looks like it's good. Maybe not that good. Okay. Okay, so I'm already in a project. So now with Vite, it's pretty easy to run. I just do npm run dev, and it should provide me a very simple website that I can work on. Okay. So already with that, okay. Now, nope, that's my cheating note. We can just open VS Code, and you can see that, okay, let's remove that. I can remove everything that I won't use. I don't need the counter as well. I'm just going to import React, just in case. And we should have something empty but still usable on that part. Good. So that's the boilerplate, right? What I want now is to show you the different things that you can do with the Nano. So generally, you don't need much with that. The first thing that you want to do is get an address, right? That's the first thing that you want to get. You want to see if your user is connected, and just to make sure that it is, you want to show him his address, so to make sure that it's using the right account and everything. So you don't have MetaMask here. You cannot just hope that you have some provider injected that is going to do the work for you. So you need to interact directly with the device. Yeah, first thing first, because again, you're working with Vite, you will just have to insert a very ugly polyfill right here. It's not a polyfill, it's just a right way to have buffer available, because at some point we're going to use it. I'm just going to paste it here. It's going to take just 5 seconds, but don't really mind that. That doesn't really matter. Okay, so that's just a quick way to have buffer available right away anywhere in the app without you having to really think about it. Okay, let's start. So I'm going to need to create a button, and that button is going to just, once you click it, it's going to return the address. So very simple thing to do. Okay, so now I will just have to create a method that is capable of asking it somewhere and just store the result to be able to display it. Again, pretty simple. I'm just going to do the React part first, so you can just skip that if you don't really care. And we'll discuss right after about the interaction that you're going to do with the Nano. Okay, so I have the boilerplate for everything. I just need to say that on click, I'm going to use the get address. And now I just need to import two of the libs that we were discussing at the beginning when I was talking about the dependencies. So the first one is what I call the app binding, so direct connection that you can have with the Nano, but also the transport that I want to use. So let's import that. Okay, now I just need to instantiate everything. Of course, we have some async await that we'll need. I will just create the transport first. Okay, and I'm just going to say, I think it's transport create, if I'm not mistaken. Okay, and now, oh, maybe, okay, I don't know if it's a promise. So just need to await that, And then I'm going to use, I'm going to create, just going to rename it with something else. Yep. Typing with one hand is hard. So I'm going to have an app binding, which is going to be also an await. No, sorry, it's going to be a new ETH app where you provide the transport. And you have basically everything you need. Just by doing that, as soon as I'm going to click, you're going to have Chrome asking you, do you want to connect to this USB device, blah, 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 blah. And if I was using a BLE, a Bluetooth, it would just ask me exactly the same thing per my device and everything. So not much to do. Now I just need to interact with it and say, yeah, give me the address for some very specific derivation path that I want to use. And I'm going to get it from my cheat sheet up, because I don't want to mess it up. And yeah, I can just say now that I want to use the app binding and use the getAddress method with the derivation path that I was using just before. And I'm going to save it with the setter that I had just before. And if I didn't do anything wrong, we should already be good, just for that. Let's try. And is my Nano connected? It's not. That's the wrong Nano. Thanks. Yep. So as I was saying, you don't really know in which state the Nano is when you want to interact with it. Here, I'm assuming that you either explain to the user that he has to open the Ethereum app on the device, but you can also, it's not available yet in a very nice state, but we have something in preparation called the device SDK that is going to help you just move the user from the dashboard, the place where you have all your apps, to a very specific app and verifying that it does everything correctly. So you don't have to do it manually. But some very good wallets like Kepler is already doing that work. So it's already doable without all of that. So I'm just going to open the Nano app. And you can already see that I have my Nano S Plus right away that is available. So I can just say, yes, connect. And of course, I broke something, because that wouldn't be nice otherwise. Oh, yeah, I know what. it's not returning exactly that. It's returning, yes, it's returning an object. Let me just change that quickly. Okay, now it should work. All right. So very quickly, I was able, without doing anything, you don't have to do any magic. You just have to provide the right transport, provide it to the instance of the app binding that you have, and it's doing all the work for you. Now let's see if I can sign something, like sign a message. I don't want to sign something too complicated. I just want to verify, like if I was connecting on OpenSea or whatever platform you want to verify the user, you can already do that directly with the Nano app. Okay, so, oh, not really readable. Okay. So I'm just going to do exactly the same boilerplate as I was doing before. This is going to be a copy-paste, basically. Hopefully you can still hear what I'm saying. Yep.
So basically just making the sign button.
Yep.
And it's going to call the derivation pass. And that's it.
Okay, so okay, I need to import buffer because in the vid context, it's not happy with it. Just import it. No, you don't want to. Okay, I'm going to do it manually then. Okay. And I just have to set the message with the result, and you will have something like the value of R, the value of S, and the value of V, which is a number, so you need to parse it manually. And we should be good. Should be a set message signature here, and last copy paste, and I think we should be good. So I created a very simple message. It would be the signature of an EIP 191 in this case. So the kind of thing that you're always doing without really knowing why, just to authenticate on many dApps today. And if I click on sign a message, of course you cannot see it because you're too far, but on my device right now, I have exactly the same thing being written, hello from etc, and I can sign it, and yes, I already got the signature from that. So now if we want to just verify that it's working correctly, I'm not going to type it directly, I'm just going to copy paste from the other project that I made. But you have a very simple way of doing an EC recover just to make sure that the address is correct and you can verify that the message was good.
So it's named verified address, not recover, but it's the same.
Yep. Let me verify that everything, oh, nope, that was not the right message. It's splitting the signature that we had before with ethers. You can just keep RS and V if you prefer, doesn't really change anything. And I'm using the method provided by ethers just to use the verified message. So again, oh, nope, missed something. What did I not close? I'm probably missing a div somewhere. Yes. Yes. OK, let's try again. So I have exactly the same address I had before. I'm just going to sign my message. And when I'm going to click verify my message, it's supposed to take exactly the same signature, do an EC recover. It's going to provide the public key, and the public key is then transformed into an address. So you get to verify if it's fitting with the signature. And it didn't work, so I broke something again. Ethers is not defined. Yes, copy pasting is bad. Doing it over again. Signing, remove that, and verify, and the address is the same. So if you were to create an authentication for your dApp, that's very easy. You don't really need, again, MetaMask or everything to do it for you. You can just do it right away. You don't need to wait for the support of any wallet. So that's for a signed personal message, so for 191. We also have two different methods if you want to verify EIP 712. One which is what we call blind signed, so you don't really know what you're signing. It's just, you know, some buffers at the end of the day that you're signing. You don't really know what we have. But there is also another method that is really just taking as an input the full message. And Ledger is providing some services for clear signing. So Ledger is going to sign some payloads that we are going to provide to the Nano so we can verify specifically the structure of the data. It's going to be capable of renaming some fields, and you're going to have something that is actually readable by a human and not with 10,000 clicks with an EIP 712 if you want. So that's also possible. You can find everything on the dev portal if that's something that you're interested about. But yeah, very simple. Again, you were able to sign that. Now I was discussing about clear signing. Let's see for a transaction, because signing a message is cool, but generally that's not the only one. That's not the only thing that you want to do. You also want to do signing very basic transactions. And most of the time, the value of the Nano is to provide you more information and verifiable information on the device, specifically for tokens, NFTs, et cetera, et cetera. So I'm going to give a very quick example again, where I'm going to show you that everything on the Nano can be creating an ERC20 token transaction transfer. It's going to be very quick. And on the Nano, if you're doing that with yours as well, either at home or here, you should be able to have everything written clearly on the Nano saying, yes, you are trying to transfer USDC. This is the exact amount. We already know the decimals. We already know everything that we need to know to make sure that once you're reaching the signature and you're validating it, everything that you saw was what you were signing directly, contrary to a big blob of data, and generally you don't really know what you're doing. This is more information that can be provided to your users, so it's actually way better experience for them, making sure that when they are trying to transfer your NFT, your token and everything, they will know for sure that nobody tampered with the data at some point. The gold data is the right one. It is the right contract and everything. That's a very important step. And we're going to do it, again, very quickly to just show you how easy it can be. Yeah, so I'm going to take a very simple transaction that I already prepared because I don't talk cold data natively. But yeah, it should be a very simple transaction for USDC at this point.
And obviously, if this transaction was correct with the right nouns and everything, then you just would have to broadcast it for it to be valid.
You don't risk anything by signing here because you're not broadcasting anything. And my nouns is incorrect. Everything is incorrect. Gas price is not good. So even if you want to try, you don't risk anything. You don't even need to be on testnet just to do that, as long as you don't broadcast the signature and you don't integrate it into the real transaction, serialize it and everything. Nothing is going to happen. Just don't show it to anyone if you don't want to have bad surprises. Okay, so I have everything I need, I think. So we also will have that as a dependency. Right now, I need to now discuss with the app binding, and you can use a new method that we added just not so long ago, that is doing everything at once. Usually, you were forced to have two different methods. The first one was calling the ledger services. It's not a great name, but that is vague enough so it can contain everything. But the goal of this call was generally to contextualize your transaction. So it's very difficult from just a serialized transaction to understand what it's doing exactly. And the goal of this call is to look through a bunch of backends, basically, where we pre-signed as ledger some data that will be verified on the Nano directly through through the public key, sorry, that is inside of the Nano. That ledgers sign exactly, yes, this is the contract for USDC, this is the parameters, etc., etc. So we are providing a bunch of stuff in advance. So at this point, the only thing that you need is to make sure that, okay, I will verify that the recipient is the USDC contract. And if so, I will check the selector of my cold data to make sure that, yes, this is exactly what you are doing. You are doing a transfer of USDC, and I can provide that information to the Nano right away. Now you have all-in-one method that is called clear sign transaction, where you can just provide the serialized data already, and it's going to do the work for you. Okay, so not much more information to provide. Like you can see, I need the duration path. So we already have that as a variable, duration path. My string as an X, as an exa string. Okay, so I'm just going to provide that. I think ethers is always prefixing with the OX, and we don't need that, so we're just going to remove the two first characters. And then I need to provide a resolution config. So it's just, if you have the information already of, yes, I know that on my dApp, the only thing that I'm doing is ERC transfer, you don't need to try to contextualize a transaction for being maybe an NFT transfer, maybe an interaction with a specific dApp that we also clear sign, et cetera, et cetera. So you can already say, yes, I know that it's you only need to verify if it's an ERC20 transaction, and that's the only thing that I will want to clear sign at this point. So it's just a very simple object, yep, where I can just say, please try to verify if it's an ERC20 transfer, and we should be good. And then I can do exactly the same thing as I was doing right here, concatenating all the signatures. Nope. Set this, and my last copy paste. Yep. Sign transfer. And I call that ERC signature. Yep. Okay, and if I didn't mess up like the 3 times before, that should be asking me, and my nano just locked itself, so I need to unlock it first. And now, and like I was saying just before, you cannot see it because it's very small, but I have way more information on my nano. Right now it's showing USDC 0.00001. I know that it's a transfer because it's telling me the address that I'm sending it to, so the real recipient, not the contract address. I know the fees. I set a gas price to 0, so max fee will be 0 as well, and I can just accept it. And if I accept, I now have the signature already there. So it's, again, no, you don't need to reinvent anything. Everything is already provided through the app binding, and you can already just use it right away with probably better UX than if you were using MetaMask. I know people are more used to use it because sometimes it's you know, it feels like a safe space. But you can actually provide more than MetaMask is doing, because MetaMask is not up to date most of the time with this library. And the end result is that you only get half of the feature that we're adding. I don't know if we have more time. Nope, we don't have more time. So you could also do the same thing with NFT transfer. We are capable of doing exactly the same thing. The only thing that you would have to change here is just say, yes, this should be NFT. You can provide everything at once if you don't know, because most of the dApp and wallets don't know exactly the context they're having. So you can just pick whatever you want. And we are also providing very soon, it's already available in the live, but you should be able to use it right away if you're smart enough. But we also have the support for domains, so we're already capable of assigning ENS with that. Only for now, only for normal transfer, so coin transfer, ether transfer, and ERC20, not for NFTs. But for everything else, it's already available. And that's it.
And that's it. Thank you so much, Kevin.